All right, let's just dive right into this explainer because today we are tackling a massive and honestly often unspoken frustration in the software engineering world right now. Look, we all know AI coding agents are promising us the moon, but the hidden costs of AI development, yeah, they are really starting to pile up on engineering teams everywhere. So we're going to look at exactly how to actually solve this.
50%. Let that sink in for a second. According to some recent research from the Pragmatic Engineer, teams that use coding agents extensively actually are shipping roughly 50% more code, which sounds fantastic, right? But here's the catch, and it's a big one. A massive half of that generated code is literally just rework from the previous week. It's the classic speed versus quality trade-off. And honestly, it gets exponentially worse the moment you step away from those simple greenfield projects and have to touch a complex existing brownfield code base. So, here is our roadmap for this explainer. We'll start with diagnosing the slop problem, then look at the foundations, followed by our fusion approach. After that, we'll see how it compares, and finally, where it works best.
Okay, section 1, the slop problem. Let's look at why AI produces slop. If you've ever felt the absolute pain of watching an AI confidently rewrite your existing codebase into a tangled, unworkable mess, well, your frustration is completely valid. But here's the thing. The models aren't necessarily broken. It's the way we're feeding them tasks that's the issue. The flaws are structural. First up, we have context contamination. See, when a model knows what you're trying to build while it's researching your existing code, it kind of starts producing opinions instead of facts. Every finding gets tainted by its eagerness to just start coding. Next is instruction budget overflow. Even frontier models can really only consistently follow about 150 to 200 instructions. So if you throw a mega prompt at it, it hits a ceiling and essentially starts rolling the dice on what to follow and what to ignore. Add in the fact that there's no automated verification, which just leaves exhausted humans to review 1,000-line PRs. And this concept of horizontal execution, where the model tries to do all the database work, then all the backend, then all the UI all at once. Nothing is testable until the whole shebang is done, which means errors just silently cascade through every single layer.
Moving right along to section 2, the foundations, methodology evolution. Fixing this slop isn't just about trying out some new random prompt trick you found online. It requires a rigorous, battle-tested evolution of structured AI coding to actually get right. This methodology traces its lineage back to 2024 with Human Factors' original Research Plan Implement, or RPI, methodology. That core insight, separating code-based research from execution. And it was successfully used by over 10,000 engineers. But as things scaled, the limitations of those mega prompts became super clear, and that led to the 8-stage QRSPI in 2025, which enforced really strict instruction budgets. And that evolution brings us directly to today's optimized fusion approach, a highly refined 6-stage pipeline.
Which brings us to section 3, our fusion approach, the 6-stage pipeline.
I am incredibly excited to share this with you because I truly see it as the definitive antidote to AI slop. It takes all that historical context discipline we just talked about and combines it with rigorous vertical execution and machine-verifiable quality gates. So here are the 6 isolated stages: questions, research, design, plan, implement, and verify. Now, we aren't going to get bogged down in the weeds of every single subtask here. The absolute most important takeaway for you is this. Every single stage is a separate command, a separate context window, and most importantly, has strict machine-verifiable gates. You literally cannot skip a stage. During questions, it extracts requirements without ever scanning the codebase. During research, it gathers pure facts without knowing what the ticket even is. Design is where you, the human, make decisions based on those facts. Plan creates a spot-checkable summary. Implement works in vertical slices, and verify automatically runs tests. The errors stop at the gates, they do not bleed into your product.
All right, section 4, how it compares. Let's stack it up against other methods.
We need to draw the battle lines here to show exactly how this methodical, gated process stacks up against other popular AI coding methodologies you're probably already familiar with. First up, let's look at spec-driven development. Look, spec-driven frameworks are fantastic for sure, but they are fundamentally designed for greenfield-first projects. If you're starting from scratch, they're great. But our fusion approach is explicitly brownfield first. It features dedicated code-based research and declaration-driven verification because, let's be real, in the real world, understanding the messy, current patterns of an existing codebase is absolutely critical before you propose a single line of new code.
Next, how does it compare to its direct ancestor, plain QRSP? Well, while plain QRSP relied on prose plans and manual human review, the fusion approach upgrades this massively. We basically replace those prose plans with machine-verifiable declarations and automated validation pipelines. It builds in type checking, semantic checks, and browser checks automatically at every single phase boundary, so you aren't relying purely on a human trying to spot a needle in a haystack.
Okay, let's talk about vibe coding, or unstructured prompting. We've all done it. But the chaotic reality is that this shoot-from-the-hip method heavily spikes code complexity by roughly 41%, and static analysis warnings jump by 30%. You might feel like you're moving fast in the moment, but you are leaving a massive trail of technical death in your wake.
So when we place vibe coding next to the fusion approach, the contrast is just stark. Vibe coding is unstructured, horizontal execution. Honestly, it is the antagonist to actual software craft. The fusion approach, on the other hand, provides upfront constraints, vertical execution, and crucial human decision points at every single boundary. If a subagent gets confused in fusion, the automated tests and human gates stop those cascading errors dead in their tracks. No more digging through a spaghetti codebase to find out where things went wrong.
Section 5. Where it works best. Ideal use cases. Now let's be completely objective here. A heavy-duty 6-stage pipeline is an incredible tool, but it is a specific tool for a specific job. It might actually just be pure overhead in the wrong scenario. On the best fit side, this approach absolutely shines for production SaaS environments with existing code bases, highly regulated industries where ship fast, fix later is just completely unacceptable, and complex features spanning multiple layers. It's basically perfect for teams of 2 to 10 engineers who really need solid alignment. But on the not ideal side, let's be honest with ourselves. Do not use this for a quick one-off script, a simple single-file change, or a pure greenfield project. The pipeline overhead there would vastly exceed the value of the code.
But when you do use it in the right environment, look at the massive leverage you gain. With standard agents, human reviewers are stuck trying to catch logical flaws in a chaotic 1,500-line pull request. It's a nightmare. With the Fusion approach, you are only reviewing a spot-checkable 250-line design document and plan summary. The orchestrator and the automated tests handle the rest. You literally get your time back, and your codebase quality goes up.
We've covered a lot of ground in this explainer today, but I want to leave you with this final powerful thought. The goal is not maximum speed. Going 10x faster simply doesn't matter if you just have to throw it all away in 6 months because the codebase collapsed under its own weight. The true goal is the maximum speed at which quality is maintained. 2 to 3x with craft beats 10x with slop. Every single time. So, my provocative question to you is this. Are you ready to stop throwing away code and finally choose craft over slop in your AI workflows? Thanks so much for learning with me today, and I'll catch you in the next explainer.